Hi everyone, for today's lesson we are going to learn how to solve quadratic equations using square roots, and we are also going to model vertical motion we're also going to do vertical motion models for objects. With our learning objectives being I can solve quadratic equations using square roots and use the vertical motion models for falling objects. So this is going to be for falling objects. So let's go ahead and talk about what it means to solve quadratic equations using the square root method. So far we've already learned how to solve quadratic equations using factoring. But sometimes factoring isn't the best or most appropriate approach. You can tell that whenever you have just an x squared and no other, there's no other b value. So whenever we had it in the form of ax squared plus bx equals c, we would use factoring. For all of our equations that we're going to be talking about, we don't have a bx involved. So therefore, using square roots is actually going to be the better method. Now you can use square roots to solve some types of equations. If s is greater than 0, and then the equation x squared equals s has two real solutions. If s was smaller than 0, it would have imaginary solutions, and that's something that we're going to be talking about very soon. We would have two real solutions. It would be x equals positive square root of s and x equals negative square root of s. And so what we would do is we would take the square root of both sides, and the square would eliminate the square root, leaving us with two solutions. And there's always going to be two solutions, a positive solution and a negative solution. Because remember that solutions represent x-intercepts. They represent roots of the equation. And a lot of quadratics have two x-intercepts. So you have to kind of keep that in mind. The best time that you would use quadratics, if you see either a parenthesis squared only in the equation, or if you see a parenthesis squared only in the equation. If you see this, like it's in, the equation is like in a vertex form kind of way, or you see just an x squared, square roots is the most appropriate method. So for example number 1, we want to solve the quadratic equation just like we would solve any equation. We would want to get x alone. So in this case, I need to get x squared alone. And I'm going to divide both sides by 5. And when I do that, I end up with x squared is equal to 16. Now I'm going to take the square root of both sides. And when I do that, I end up with x equals not just one solution, but two solutions. And that is plus or minus 4. For letter B, my goal is to get that x squared alone. So I'm going to actually write down these steps. Step number 1 is to get x squared or the parenthesis squared alone first. And then step 2 is we're going to take the square root of both sides. And I'm going to put down a remember your plus or minus as a part of your answer. Plus or minus is absolutely important because you have to remember that there's possibly a positive x-intercept and a negative x-intercept. Let's go ahead and look at letter B. Let's get that x squared alone by adding 16 to both sides. When I do that, I'm going to be left with 2x squared is equal to, and it looks like that is going to be 50, excuse me. And now I'm going to divide both sides by 2 so that I can get that x squared alone. And when I do that, I'm going to be left with x squared is equal to 25. I'm going to take the square root of both sides, and when I do that, I'm left with x is equal to plus or minus 5. Let's look at letter C. For letter C, I need to get rid of this 1/4 that's on the outside of the parentheses. Whenever you want to get rid of a 1/4, the best approach is to multiply both sides by the reciprocal, or the common denominator. The only denominator that we have in this case is 4. So I'm going to multiply both sides by 4. what's going to happen is that the multiplication of 4 will eliminate the division of 4, leaving us with x minus 6 squared is equal to 32. Now that I have my parentheses squared, don't worry about that x minus 6 quite yet. We're going to take the square root of both sides. And when you do that, the square will eliminate the square root, leaving me with x minus 6 equals. Now, 32, I know that 32 is equal to the square root of 16 times 2. The square root of 16 is 4, so that's 4 square roots of 2. But because I took the square root of both sides, this is going to be plus or minus 4 square roots of 2. Just like we had plus or minus 5 and plus or minus 4 in the last problems, we're going to have a plus or minus on the other side. So now we need to get x alone, and I am going to simply add 6 to both sides. And when you write your answer, the 6 will go in front, then we'll have plus or minus 4 square roots of 2. So whatever you're bringing to the other side, we will have our plus or minus in front. I would like you guys to go ahead and try the team, pair, and solo on your own, and then be ready to discuss the next time I see you in class. And let's go ahead and talk about vertical motion models for objects. So a vertical motion model is h of t is equal to negative 16t squared plus v sub 0, so that's a little 0, times t, plus h sub 0. Let's talk about what these variables represent. So h of t represents the height of your object after so much time. T represents time in seconds. V sub 0 represents your initial velocity. And h sub 0 represents your initial, which initial is another word for starting, height. This height, I forgot to mention, is in feet. Now, please note that when an object is dropped, v sub 0 is equal to 0. So your initial velocity is 0. This is true if your object is dropped. If it is not dropped, you'll see other information saying that your initial velocity was something. It's very specific. So let's go ahead and look at example number 5. It says a water balloon is dropped from a window. So it is dropped. So there's my dropped. That tells me that my v sub 0 is going to be equal to 0. It is dropped from a window that is 50 feet or 59 feet above the sidewalk. So this is where it's starting off. It's my initial height. H sub 0 will equal 59 feet. How long does it take? So we want to find time. How long does it take for the water balloon to hit the sidewalk? So let's go ahead and talk about these pieces. So I don't know what h sub t is. That's what I don't know. That is recapping. So we have h of t is equal to negative 16t squared plus v sub 0t plus h sub 0. Let's go ahead and identify information. A water balloon is dropped, so that tells me v sub 0 will equal 0. From a height of 59 feet. My time is what I do not know. My height when it hits the sidewalk. Let's think about what that is. When you hit the sidewalk, what's your height? 0. So your height after so much time is supposed to equal 0. We need to find what time is. So plugging all of these values into our equation, I'm going to say 0 equals, because you're hitting the ground, that's going to equal negative 16t squared plus 0t plus 59. I'm going to simplify this problem because I have 0t in the middle. So that means I'm going to have 0 equals negative 16t squared plus 59. Using our skill that we just learned about solving using square roots, whenever you just have a term squared, that is your clue that you'll be working with square roots. So I'm going to subtract 59 on both sides. When I do that, I'm left with negative 59 is equal to negative 16t squared. I'm going to divide both sides by negative 16, and I'm left with t squared equals 59 over 16. We're going to round our answer to the nearest hundredth this time. So I'm going to take the square root of 59 over 16, and when I put this in, I'm not going to put in like 59 over 16 first. Instead, I'm going to do like that whole fraction of the square root of 59 divided by 16. And when I do that, I'm left with 1.92. Now remember, we're solving an equation. So that's going to be plus or minus 1.92 is equal to t. But does plus or minus make sense? No. Negative 1.92 seconds does not make sense. So therefore, our answer is simply positive 1.92 seconds. So what we're going to say is after 1.92 seconds, the water balloon hits the ground. And that is the end of our lesson today. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.